Imagine me telling you that at this very moment in the universe, there is a place where, for 1 second, the time freezes, space collapses, and reality simply is not there anymore, as we comprehend it. A place from where nothing, not even light, can escape. But where do we start to comprehend something so alien? Something that apparently even manages to break through the very bonds of physics? To explain that, we have to start at the very beginning. Inside a dying star. Take a star, for instance, much larger than the sun. It would burn its fuel over a few millions of years and maintain its balance between the tugging gravitational forces pulling it in and nuclear reactions pushing it outward. How does it behave when this fuel is exhausted? Gravity wins. The star collapses under its own weight, shrinking to a tiny point, crushing all its mass into an unimaginably small space. It is here that a black hole now comes into being. Imagine all that mass, all that power, compressed into a singularity, an infinitely dense point with a near magical pull. Now that we have seen one black hole born, let's examine its anatomy in detail. But be warned, this is where things get really weird. First, there's the event horizon, sometimes known as the point of no return. It's the boundary marking the edge of the black hole, beyond which the gravitational pull becomes so strong, nothing, not even light, can ever escape. And then, of course, there is the singularity itself, the center of a black hole, where all the mass has fallen into one point. The laws of physics break down, and nobody really knows what happens inside. At first glance, it may just appear to be a sort of cosmic vacuum cleaner, sucking in anything in its vicinity. But there's more, much more. Wrapped around many black holes is the accretion disk, the glowing, whirling vortex of gas and dust. As matter falls toward the black hole, it heats up to millions of degrees, shining brightly as it spirals down the cosmic drain. And sometimes, black holes shoot out high-speed jets of energy, so powerful they can stretch across galaxies. For something that lets nothing escape, black holes can sure make a lot of noise, but not all black holes are created equal. In fact, there are 3 main types. First, we have stellar black holes, named so because they form from the collapse of individual stars, as we saw earlier. These are the most common, and they are usually 10 to 20 times the mass of our Sun. Next are the supermassive black holes. Giants in the centers of galaxies. Enormous monsters with billions of times the mass of the Sun. In fact, there is one at the very center of our own galaxy, the Milky Way. But don't be scared. It is distant enough that way would be in no danger yet. And finally, there's a mysterious third category, primordial black holes. These are still just theoretical, but some scientists believe they could have formed shortly after the Big Bang, and they might be as small as an atom, but with the mass of a mountain. Now, let's get hypothetical. What if you were brave, or crazy enough to fall into a black hole? What would you experience? You approach it, and right away, you'd feel the strong tugging due to gravity. The weirder things get, the more you approach. The time would appear to slow down. It would look to another observer that you just sat there, frozen in time at the edge of the event horizon forever. To you, it's a whole different story altogether. You'd be stretched literally. Scientists refer to this as spaghettification. The gravitational forces between your head and feet would be so different that you'd be stretched out into a long, thin noodle of atoms. Eventually you cross the event horizon. Well, what happens then? Nobody really knows. You'd be crushed down into the singularity. Or maybe you'd pass into another universe. The truth is, black holes remain one of the greatest mysteries of science. But even black holes can't live forever. Thanks to a mind-bending theory courtesy of physicist Stephen Hawking, we know that black holes gradually lose energy through a process called Hawking radiation. Over billions of years, a black hole could finally evaporate, leaving nothing behind. So, in the end, even these titans of destruction aren't eternal. Black holes are cosmic wonders, mysterious, terrifying, and awe-inspiring all in one breath. They challenge everything we think we know about the universe, and yet they hold the keys to some of its biggest secrets. And with that said, thanks for watching, and until next time.